In this question, we're asked to evaluate the natural logarithm given here if natural log x equals 2, natural log y equals 3, and natural log z equals 5. To do this, we will expand this logarithm as much as possible and then perform substitution for natural log x, natural log y, and natural log z. So if we take a look at the given logarithm, notice how this quotient here involves negative exponents. So if we wanted to, we could rewrite this fraction here using positive exponents. For example, if we have x to the power of negative 2 divided by y to the power of negative 3 z to the fourth, if we move x to the negative 2 to the denominator, it would change the sign of the exponent to positive 2. And if we moved y to the negative 3 up to the numerator, it would change the exponent to positive 3. So this fraction is equal to y to the third in the numerator, and then the denominator would be x to the second, z to the fourth. So we could rewrite the logarithm using this fraction instead, but let's go ahead and use the logarithm in the current form. So because we have the natural log of a quotient, we can write this as a difference of two logarithms using the quotient property of logarithms here. Where if we have the log of a quotient, we can write the log of the numerator minus the log of the denominator. So this is equal to natural log x to the power of negative 2 minus natural log of y to the negative 3 times z to the fourth. And now because the second log is the natural log of a product, we can expand this as a sum of two logs using the product property of logarithms given here. But we have to be careful here because if we're subtracting this log, we also have to subtract the expansion or the sum of the two logs. So this would be equal to natural log x to the negative 2 minus, and then in brackets or parentheses, we'd have natural log y to the negative 3 plus natural log z to the fourth. Now we can apply the power property of logarithms given here, where we can take the exponent n and move it to the front so we have a product of n times the log. So we can take the exponent of negative 2, move it to the front so it's the coefficient, take this negative 3 and move it to the front, and move this 4 to the front. So this would give us negative 2 natural log x minus the quantity negative 3 natural log y, and then plus 4 natural log z. Now before we perform the substitution, let's go ahead and clear these brackets. So because we have subtraction here, we can think of distributing a negative 1, which would give us negative 2 natural log x, and then negative 1 times negative 3 is positive 3, so plus 3 natural log y, and then negative 1 times positive 4 would be negative 4, so we have minus 4 natural log z. And now in this form, we'll substitute the values for natural log x, natural log y, and natural log z. So we would have negative 2 times natural log x, which is equal to 2, plus 3 times natural log y is 3, minus 4 times natural log z, where natural log z is positive 5. So this would be negative 4 plus 9 minus 20. Well, negative 4 plus 9 is 5. 5 minus 20 is equal to negative 15. So the given natural log is equal to negative 15. I hope you found this helpful.